This hold apart trick where we multiply by the subscript works when we're going from molecules to moles. It works when we go from molecules to atoms, and it works when we go from moles to moles, but not when we go from grams to grams. We're going to now take a look at an example where we go from moles to moles. I have 12 grams of calcium nitrate. I need to get the moles of calcium nitrate. Molecular weight of calcium is 40. I have 2 nitrogens. I have 6 oxygens, giving me a grand total of 164. To get the moles of calcium nitrate, I'm going to use the grams of the whole thing with the molecular weight of the whole thing. So 12 divided by 164 gives me 0.073 moles of the whole thing. I'm going to label this right here, also as 0.073, my answer to that part of the problem. From here on out, it's easy. I've done most of the hard work. Just like we did in the last part where we went from whole to part, from molecules to atoms, when we're going from moles of whole to moles of part, we're going to multiply by the subscript, or by the number in each. How many calciums are in each molecule? Just 1. So to go from here to here, I'm going to multiply by 1, giving me 0.073 moles of Ca. For nitrogen, what do I want to multiply by? How many nitrogens are there? This 2 distributes. I have 2 nitrogens, so I'm going to take those moles and multiply by 2. 0.073 times 2 gives me 0.146 moles of N. Okay, and what about for the moles of oxygen? I've got 6 oxygens in each. So to go from here to here, I'm going to need to multiply by 6. 0.073 times 6 gives me 0.439 moles of O. I know I've said this before, but I want to say it again. When I go from whole thing to part, I can multiply by the subscript if I'm going from molecules to atoms or moles to moles, but not if I go from grams to grams. Grams to grams we looked at in video number 1 of this lesson, where we use percent composition as a much easier way to do that.